Okay, good morning once again. Today we're going to continue our discussion on multiple linear regression. So far, what we have done was to use the wage data set, and we regressed hourly wage on education. So this is a simple linear regression model because we're only using one predictor, which is education. And when we run this, we learned last time that the estimate here, 0.54, is the slope it's the marginal effect of education on hourly wage, and it's statistically significant. Okay, and we said that this means that for every $1 1-year increase in education, there's a corresponding $0.54 or 54 centavos increase in hourly wage ceteris paribus. Now the intercept, which is supposed to be the value of your hourly wage when your independent variables are zero. In this case, education is zero. The value is negative 0.90. Okay. However, it's not statistically significant because the p-value is 0.187 and it's greater than 0.05. So the null hypothesis here is that B0 is equal to 0. The null hypothesis here is B1 is equal to 0. Of the two, we fail to reject the null hypothesis for the intercept. However, we said that as regards intercept, we still include it in the model, even if it's not significant. For the independent variables, if they're not significant, then we will not include them in the model. Last time we looked at how we compute for this. So the education is simply we learned about the formula of that. So based on OLS, ordinary least squares, it will give us the value for education, the formula for education, which is just the covariance of your X and Y. In that case, education and hourly wage, and then the variance of X, which is the variance of education. So if we compute for that, we got this. And we were able to prove that last time using the formula, but if you recall, class, this one, this is just the covariance of your X and Y divided by the variance of your X. And you notice that the denominator, this is not present because it just divides by itself. No? This is divided by n minus 1. This is also divided by n minus 1. Okay, but the complete formula is divided by n minus 1. Okay, this should be divided by n minus 1. Let me just quickly annotate that. This one should be divided by, oops. Okay. This is divided by n minus 1. My digital pad is not working. Okay. I hope you can understand my handwriting here. Divided by n minus 1. Okay, so this is n minus 1, n minus 1. So this cancels out. Okay, but the formula is still the covariance of X and Y divided by the variance of X. Okay, so this can be written as the covariance of X and Y. Okay, notice there's no squared here. Okay, because here this is X and Y. And then the variance of X, which can be written as the variance of X. So double X there, or this can be written as the variance of X, just a single X here, and then naka-squared. Okay, so just a very quick review of your basic statistics lessons. Okay, let's clear this. Okay, so and then we computed also for the intercept. We were able to show that indeed this is negative 0.9. Okay, we learned how to interpret that, and then we also learned how to compute for the standard error, which is this one. This is the standard error of your slope. This one. There's also a formula for the standard error of your intercept, but we didn't look at that anymore. Okay, and then we also compute for the t-value. Okay, and then once we get the t-value, you can now compute for your p-value. And we said, class, that you can use the t-value or the p-value in order to come up with an inference, okay, if your null hypothesis should be rejected or not rejected. We said once again that this is our null hypothesis. Beta null is equal to 0. Here, beta 1 is equal to 0. So we can use either the t-value or the p-value to come up with an inference. And for the p-value, we said that our level of significance is 0.05. Okay, so we compare our p-value to our level of significance. If the p-value is small relative to your level of significance alpha, then we reject the null hypothesis. In the case of education, we can see here that this is a number that has so many zeros. Okay, it's practically 0. And then, so it's less than 0.05, therefore we reject this null hypothesis. So that's our null hypothesis, H sub O, that B1 is equal to 0, which means, class, we reject this. And there's we have a strong statistical reason to believe that your slope, B1, slope for education, is a value other than 0. Okay? And the 3 stars here indicate that it's statistically significant at the 0.001, at the 0.1% level. Well, actually, class, we said that the value here, the p-value, clear natin to. The p-value here, this one, okay, it's not the actual p-value because when we computed that, ano lumalabas ang p-value natin? To recall, class, ano lumabas ang p-value natin? Yung probability. Di ba we talked about this formula? Ito, the p sub t, di ba? And we looked at 2 ways to compute for it. So let's use this. Kailangan masolve ko muna itong t-stat na to. B1, hindi ko pa lang na-solve si B1. I have to go back here and solve for B1. Okay, solve ko muna to. Si B1, yan si B1 natin, which confirms the value. And then I'm going to, my mouse is again acting strangely. So B1, na-solve natin. And then yung standard error ni B1, sinolve natin. But I'm interested in solving our t-value, this one. So kailangan natin si standard error also. So this one, to solve for the standard error, yan, so that we can compute for the t-value. So this one is our t-stat, okay, 10.1665, and it confirms what the table generated, okay? And then when you have the t-stat, you can now compute for the p-value. Okay, so here, let me compute for the p-value here. Okay, so the p-value here is, okay, and then, sorry, should be times 2, no? So that's only one side of the tail. So times 2, ito yan, no? 2.7 to the negative 22. And we said that it's not the same as the p-value here. Yung una na generate dito na p-value, which is just, where's that? To the negative 16 lang siya. No? Here, 2 to the negative 16. when in fact it should be 2e to the negative 22. Okay, so we said that that number, 2e to the negative 16, is the smallest positive floating point, no? Floating point number. So it's the smallest non-zero number. Okay, anything lower than this will be considered as zero. And how did we prove that, class? Okay, tatanggalin itong options ng 17 digits, no? Okay, I'm creating here a number, okay, this one, called X, which is that machine $double.eps. So X is this one. X is 2.22 times 10 to the negative 16, which is the smallest floating point number, which is treated as non-zero. Okay? How do I prove that? If I add 1 plus X and ask, is this equal to 1? Kasi kung 0 to, class, dapat ang answer dito true, di ba? If this would be treated as 0, si X, itong number na to, so dapat 1 plus X, when we're testing it, should be true. Dapat true yung lalabas dito. If I run this, false siya. No? Ibig sabihin, 1 plus X is not equal to 0. Okay? If I test this one, gawin kong, okay. Sorry. I go down. Sorry, mas mabilis lumakad yung brain ko kaysa yung sa kamay ko. Okay, Control C, Control B. What if I make this 1 plus X, is it greater than 1? Okay? So pag dinagdag natin yung 2.78, will that be considered as greater than 1? Let's see. Yeah, true. No? True. It's a number greater than 1. Right? Okay. Now, ito naman, kunyari, itong generated an X1 number. X1 is yung 2 point, this one, the smallest number, and then binawasan ko pa ng a small number din, no? 2.2e to the negative to the minus 16. So if I generate that number X1, okay, so this is now your X1, and then if I add 1 plus X1, is it equal to 1? Let's test. You can see the difference between the first one and the second one. For this one, yeah, 1 plus X1 is equal to 1. That's true. Why? Because this X1 is a number less than the lowest floating point number. Kasi nagbawas pa ako ng small number. So ibig sabihin na to si X1, okay, this will now be treated as 0 because it's lower than the smallest floating point number that are considered to be non-zero. Okay, I hope that's clear, class, yung concept na yun. Okay, that's just to make sure that we understand what these numbers are. Actually, class, okay, if I want to get the Control Alt I, let's see. Let me get the summary ng, okay, let's get the summary of kanina, ano ba ginamit natin? Mod 1, no? Summary ng Mod 1. Okay. And then, dollar natin, dollar coefficients. Let me just check this. What do we get? Coefficients. Okay. Kasi class, kung ano lang, okay, let me do this. If I just get mod 1, di ba pag nag-dollar ako sa kanya, di ba sino mod 1, ano to, list, di ba? So I get the coefficients, it will just give us the 2. Okay? It will just give us intercept and education. Pero, if I use the summary of mod 1 and then get the coefficients, okay, surprisingly, it will give us a different answer. Yan. All right? So I'm getting the summary of mod 1, which is our regression model, and then get the coefficients. let's run this. Okay, so this is a nuance of R, no? Okay, you will not, I don't see this in ano eh. Mag-round lang ako dito, round, lalaki kasi, no? I'll round it to 3 decimal places para mag-cancel lang. Okay. Take a look at this, class. Okay, kaso pag nag-round ako, hindi natin makikita si ano, yung p-value ni ano. So tanggalin ko ulit, ha? Okay, sorry about that. Control C. Okay. Summary ni mod 1 and then coefficients. I'm not going to round it to 3 kasi hindi natin makikita yung p-value. Run this. Yeah, there you can see now, class. Yung p-value dito, tama na. Huh? Okay, unlike pag yung summary ng mod 1, nag-aano siya, ine-estimate niya dun sa highest na floating number. Dun niya lang dinalagay. But if you want to get really the value of your p dito sa education, okay, you use this summary ni mod 1 and then get the coefficients. That will give you the actual p-value. Okay, and so based on this, for intercept, this is to the -1, so that's 0.187. So that's greater than 0.05. So the inference here is that we fail to reject the null hypothesis. That B sub 0 is equal to 0. Okay, on the other hand, say education, which is the hypothesis is B1 is equal to 0, we definitely reject the null hypothesis that B1 is equal to 0. Because your p-value here, okay, is much less than 0.05. And so here we have the actual, which agrees with what we have here, di ba? You know, 2.7825. Okay? 7825, di ba? Parehong-pareho. Okay, so we were able to show, we computed for the p-value, the actual, okay, which is this one, using the pt function, ito. All right? And we were able to extract also using this function, summary ng model 1. Okay? All right. Then we said there's another way to infer whether to reject or to fail to reject the null hypothesis. It's using the t-value. So how do you use the t-value in order to determine whether to reject or fail to reject the null hypothesis? Well, the answer is, class, ang answer dito ay, ano? Ano yung answer dito? Compute natin t-critical. No? Okay, so we compute for the t-critical value. All right, so the formula is QT. That's the t distribution. And then we're using the left tail 0.025. And then this is degree of freedom, which is n minus k minus 1. We have only one predictor and one for the intercept. And then lower the tail is equal to false. Because sabi nga natin, di ba, if you recall, yung t-stat natin, yung t-distribution natin. So we're just using this, yung lower tail na to. And remember, okay, so dalawa to. If we're using an alpha of 0.05, on the left-hand side, you have your 0.025. On the right-hand side then, ito yung 0.025. So we just use this one, no? 0.025 for this, okay? And then this is your degree of freedom, and lower that tail is equal to f, okay? So it will give us the value here. And we know that it will give us a negative value here. If you want the positive value, which is this one, okay, then you will have to use, pwedeng lower that tail is equal to true. Okay, then this should also be, ito, 0.025 din to. Okay, so we did this last time. And what we're getting is, when we ran this last time, ito, what did we get, class? Saan na yung ano ko? What did we get? Ito pala na K31 drawings. Then X. Okay, so when we run this, okay, 1.96, no? 1.96. Okay, which means, class, that whether your t-value is negative 1.96 or positive 1.96, okay, you reject the null hypothesis. So less than 1.96 and greater than 1.96, okay, we reject the null hypothesis. For the intercept, it's negative 1.32. So asan yun? Okay, when we plot this between negative 1.96, diba? Okay, your negative 1.32 is here. Negative 1.32. So, wala siya dun sa rejection region. Ito kasi yung rejection region natin. Any t-value that's lower than negative 1.96, nasa rejection region yan. Same thing here with the 1.96 here. The right-hand side. So yung intercept natin is here, negative 1.32. That's why we fail to reject this. Yung intercept natin, yung B sub O is equal to 0. On the other hand, sa education, our t-value is 10.16, so it's here, no? To the right of 1.96. Nasa rejection region siya. So that's why we are rejecting the null hypothesis that our B1 is equal to 0. Okay, so this is just a very quick review of your stat, yung mga basic stat natin dati. Okay, if you have forgotten it, I hope this serves as a good review for us. All right, meron pa tayong isang output dito, no? Ito na hindi pa natin na-discuss, so we're going to quickly discuss this. How about this one, class? Ito. Ito, no? This one. Residual standard error. Ano to? Ano tong standard error of the residual? Where did this come from? Yung 524 degrees of freedom, alam natin yan, di ba? Kasi yung degrees of freedom natin will be the number of data observations minus k minus 1, di ba? Ang k natin, class, is, what's our k? Our k is the number of predictors. No? Since isang predictor natin sa education, then 1 to. And our n is n minus k minus 1. So our n is 526 yung observations natin, minus 1, minus 1. So our degree of freedom is 524, which we can actually get. No? We can get that via yung model 1 natin, mod 1, and then $sign, yung df.residual. Sige, pakita natin. No? Paki-ano lang, class, paki-confirm, paki-check nyo, paki-sulat nyo sa console nyo, mod 1, $df.residual. What are you getting? What are you getting, class? Hello? We just want to see kung tama nga talaga itong 524 degrees of freedom na to. Okay, Leslie, how did you get 524?
Sir, input mod 1 $sign df.residual.
Yeah, correct. Tama, no? Model 1, yung regression model natin, degree of freedom ng residual natin, which is n minus k minus 1, which gives us 524. Okay? So makukuha natin yun sa list natin ng mod 1. Okay. Now, how about this? Meron tayong f-stat dito, may degree of freedom 1, may degree of freedom 2. So dalawang degree of freedom dito, no? Degree of freedom 1 will be the number of predictors. Degree of freedom 2 will be your n minus k minus 1. No? So you have here 2 degrees of freedom. Okay, one is the degree of freedom for the predictor, which is 1, kasi isa lang naman yung predictor natin sa education. And then meron tayong p-value naman dito, which is the same as your p-value dun sa regression table natin. Tapos meron tayong multiple r squared dito, 16.48. Tapos may adjusted r squared pa, 16.32. So our object now is to understand where this is coming from, no? So we want class na hindi tayo parang blindsided to how this were computed. So it would be good for us to know saan nanggaling yan, tapos kung ano ibig sabihin yan. Okay, so for us to understand that, kailangan natin maintindihan yung concepts ng ito. So let's go here now. Okay, I gave these formulas to you. Balikan natin tong concepts ito, no? Which I'm sure you discussed in your stat dati. So yung SSR, ito, compute for SSR, SSE, and SST. This is supposed to be capital T. Okay, SSR, SSE, and SST. So careful lang tayo, class, kasi different authors have different nomenclatures. Different authors have different ways of designating the variable name. No? For our purposes, SSR will be the sum of the squares of regression. Okay, which by interpretation means ilang percent ng variability ng dependent variable natin ni hourly wage can be explained by your regression model. Okay, yun ang SSR. How many percent of the variability of your independent variable can be explained by your model? So that's your SSR. Okay, yung so another name for this is your explained variance. Sulat ko nga dito. So this is your explained variance. So variance ng ano yan ng dependent variable natin. Si SSE naman unexplained. So that's your unexplained variance. Ilang percent ng variability ng dependent variable natin cannot be explained by our model. So others call this SS error, no? Although hindi naman talaga siya error, it's more of residuals. Okay? Kaso, ginamit na natin dito yung R. Kaya hindi natin pwedeng gamitin yung residuals dito. And then yung SST, ito yung sum of the squares of your total. In other words, what's the total variability of your dependent variable? So total variability, explained variability is your SSR, and then unexplained variability is your SSE. So, okay, may formula tayo dyan, no? But before we do that, class, let's, okay, did I share this with you? Ito, may code ba ito na ganito? If not, class, I'll just like to chat this. Okay, paki-copy nga to, no? Paki-insert tong object na to. Okay, this one. And then also this one. I'm just going to show you what this will generate. Okay, so for the first one, ito, there's an object, there's a function called augment. Augment, and that comes from the Broom package. And then ito sa augment class, magbibigay siya ng table that gives us the most, sabihin natin, important points, important items, important data from our model 1, from our mod 1. Okay, so I'm creating this object called mod 1 recid to stand for residuals. And then I'm just going to use the round function para 3 decimal places lang kasi magsi 6 or 7 decimal places siya, masyado mahaba. And then I'm going to use the augment function from Broom. Okay, so if I run this, there, so meron na tayong mod 1.recid. So it's also 526 observations of 8 variables then. So if I open this, okay, take a look at this. So meron tayo dito mga mga metrics, no? Ito yung hourly wage natin. Ito yung observed education, okay? Ito yung fitted value natin. Okay? Ito yung residual natin, the difference. So that's 3.10 minus 5.05, that's negative 1.95. And then we have here dot sigma, okay, which we're going to discuss next time na lang. Importante sa atin ngayon, itong Cook's distance at saka yung standardized residuals. Okay? Yung standardized residuals is just your normalized residuals. So in other words, kukunin mo, kunyari itong residuals natin, di ba? Standardized lang natin yan. Okay? And that's very easy. Kukunin mo lang yung mean yan, mean ng residuals, and then resid minus the mean of the resid. Di ba? And then over n minus 1. Di ba? Kasi di ba yung standardized value is x minus x bar okay, over n minus 1. Right? So that's your standardized residuals. And then this is your Cook's distance. Si Cook's distance, gagamitin natin later on yan for residual diagnostics. Kasi gusto natin malaman kung meron tayong tinatawag na influential data point, which we're going to discuss in the future, no? Next meeting siguro. An influential data point is a data point that can affect your model. Okay, so may may parameter yan. Kung masyado mataas yung Cook's distance, ibig sabihin nun, the presence of that data point is affecting your model. So kung tanggalin natin yung data point na yun, magbabago yung regression model natin. Okay, but I just wanted to show this to you para malaman natin na may may mga let's say may mga tools that we can use for model diagnostics in the future. Okay, so balikan natin to. All right. Okay, so this one. Okay, ilalagay ko siya dito, no? Wait lang ha. Okay, yung mga F-stat kanina, yung sinabi ko yung nasa model natin na hindi pa natin na-discuss. Okay, let me put that here. Control V. All right. This one, the one that I showed you a while ago, yung may a degree of freedom 1, degree of freedom 2, yung residual standard error, multiple R squared, adjusted R squared. Our objective now is to be able to understand where is this coming from. And actually, that's coming from what we call analysis of variance. So, okay, I don't think I gave this to you, but kindly write this, no? Hindi ko na ika-copy paste para kayo na mismo sumulat. So we're going to create an object called ANOVA 1, analysis of variance 1, and then we're going to use the stats package, and then the function is ANOVA model 1. Okay, here I'm just rounding off the output to 3 decimal places. So this is from the stats package, which you don't need to install because it comes already preloaded with R. Okay, and then it will generate an analysis of variance, which I'm sure you discussed before in your elementary stuff. No? So if I run this, okay, take a look at this. Run, and then si ANOVA. No? So i-print lang natin to. ANOVA 1. ANOVA 1. All right. So take a look at this class. Meron tayong ANOVA, no? Analysis of variance. And then it defines to us what's our response variable. And then, okay, ANOVA ng model 1 to, di ba? Model 1 consists of your predictor, which is education. Okay? So ibig sabihin to class, ito yung SS. This is your SSR. Education is your regression, di ba? Ito yung ano natin, ito yung this is our ulit ako, no? Education is our regression. Residual is our error term. No? So this one class SS, sum of the squares. So this is your SSR. Okay, this is your SSE. Okay, I mentioned a while ago to you that there are 3 things that we need to look at. Your SST, your SSR, and your SSE. Okay, so this, I'm confident that this was discussed to you before, but maybe not in the context of R, or maybe just in Excel. So here we're just diving deeper into this. Okay, because we would want to understand where this is coming from and how this is computed, no? So ito class, yung sum of the squares, yung SS yun. And for education, this is our regressor. So this one pertains, as I said a while ago, this is your SS regressor. Okay, and just be careful kasi yung iba, ang tinatawag dyan, SSE, baliktad, no? Explain. Ito naman yung residual. So depending on the text that you're reading. In our case, this will be your SSR. So ito yung variance na sum of the squares na unexplained. Ito yung explained, ito yung unexplained. So makikita natin dito na mas konti yung explained kaysa unexplained. And then we have here MSE, no? Mean square. Okay, mean square error, MSE siya. And it's actually equivalent to your SS divided by your degree of freedom. Okay, so whatever your SSE is divided by your degree of freedom, that will be your MSE, mean square. Ito, ganun din, no? 5980.7 divided by 524, you get 11.41. Once you get your MSR, mean square ng regression, divided by MSE, mean square ng error, you can now compute for your F value. Your F value is simply your MS, mean square ng your regression, divided by mean square ng error term or residuals. Okay? So if you divide this 1179.73 divided by 1141, you get your F value. Okay, 103.3. Okay, and then from here you can compute for your P value. Okay? So you notice, class, that this is of course an inferential statistic, no? We're testing something here. And what's our null hypothesis here? Our null hypothesis here is that your regressor B1 is equal to 0. Okay? Anong sinasabi nito dito? Na hindi mo naman kailangan na gamitin tong education as a regressor to explain your hourly wage. Pwedeng 0 na lang yan, 0 yung B1. So ano matitirang model natin? Ang matitirang model natin, just use hourly wage to explain hourly wage. Okay, which I'm going to explain in a while. Okay? So pause muna ako, class. I hope that's clear, but I'm going to show you how to compute for this. No? So ito, degree of freedom ng regressor natin is the number of regressors. No? Iisa lang siya eh. So kung may ibang regressor pa tayo, may tagwa 1, 1, 1, 1 yan. No? Kunyari, may tenure dito, so may 1 din yun. And then the residuals will be n minus k minus 1. So that's n, 526, minus k, which is the number of regressor, which is 1, minus 1 to account for the intercept that will be computed also. All right, so that's 524. Ano naman tong sum of the squares? Okay, this is your SSR, sum of the squares of your regressor. This is your SSE, sum of the squares of your error terms. And then itong MSR, which is just the quotient of your SSR divided by the degree of freedom. Pag dinivide natin yan, ito makukuha natin. Ito naman, MSE, no? So that's sum of the squares of your error terms divided by your degree of freedom number 2, this one. If you divide that, you get this one, MSE. Okay? All right? And then, yung F value natin will simply be your MSR, which is this one, divided by your MSE, which is this one. Pag dinivide natin siya, makukuha natin si F value. So, kailangan natin yung F value, class, para malaman natin kung i-reject natin to or fail to reject. You can actually get the F critical. Parang yung sa T kanina, F critical, and then once we are able to compute for the F critical, compare it with their F value. If your F value, ito yung F critical natin, no? If your F value is greater than your F critical, then this one is what we call your rejection region. So we will reject this null hypothesis. Or another way to look at it is your P value. Dito alam natin, class, no? We reject this null hypothesis that B1 is equal to 0. So consistent siya with the T value kanina, no? T value. Anong difference ng T stat kanina at saka itong analysis of variance? Well, si T stat, individual test of means. Okay, ito naman, overall goodness of fit test to. Tinitingnan natin yung kabuuan, no? Alright? Okay, pause muna ako. I've been talking a lot, class, no? I'm not sure if you're able to follow along. Okay, but I would appreciate, class, any feedback from you. Paki-chat naman, please, kung so far nagkakaintindihan ba tayo. Okay, or you want me to repeat a particular portion there? Please. Comment, please. Thank you, Nigo. Waiting for the others. Okay, thank you, Rom. And okay, good. Please don't hesitate to ask questions. Class, kung pangit yung pagka-explain ko, I don't claim to be a perfect as far as regards explaining. No? I'm sure I could still improve more. Okay, maybe there are some pointers there that was not clear to you, so please don't hesitate. Okay, how about the others? Hindi ko nakikita yung iba mag-comment. I would appreciate comments from everyone, class. Wala pa nga kalahati na.
Sir, can you repeat
Yes.
what's the difference between F value, P value, and T value?
F value, P value, T value. Okay. Yung T value, okay, ginagamit natin yung dito sa sa individual t-test natin. Okay, so yung sa regression natin, di ba? Balikan ko to. Okay, di ba nag-generate tayo ng LM, di ba? Ng linear model. Sana siya? Ayun. This one. Okay. All right. Ito yung model natin, LM, no? Okay, so here we're testing whether your predictor education is statistically significant. Pati yung intercept natin, statistically significant. So we're testing each of them individually. Separate yung pag-test natin kay intercept, separate yung pag-test natin kay education. So that the statistical test that you're going to use here is your t-stat. Kaya t-value yung ginagamit dito. On the other hand, yung kanina, yung analysis of variance, overall goodness of fit test yun. Now, hindi siya masyadong apparent dito kasi iisa lang yung regressor natin. Ngayon, if we have multiple linear regression, okay, kunyari, meron tayo ditong tenure, no? Sabihin natin may race din. Dito sa sa test of means natin, tinetest natin dito yung means na education, tinetest natin si tenure, tinetest natin kunyari si race, independently, isa-isa, no? So separate yung pag-test kay education, separate yung pag-test kay tenure, separate yung pag-test kay race, example. Now, on the other hand, dito sa ANOVA, sa analysis of variance, okay, overall goodness of fit test yan. So, what will happen here? Dito, ang null hypothesis natin dito, B1 is equal to B2 is equal to B3 is equal to 0. Okay? So, sa hypothesis, magkaiba sila. Kasi dito sa analysis of variance, ang tinetest natin, yung sabay-sabay, overall goodness of fit test, B1, B2, B3, assuming there are 3 predictors. Dito sa t-stat, isa-isa yon. Ang hypothesis natin dito, B1 is equal to 0, B2 is equal to 0, B3 is equal to 0. Okay, yun na sa t-stat. T distribution natin kasi individual test of means yun. Ito naman, analysis of variance. So variance ang tinetest natin dito. Ito sa t-stat test of means, yung average, yung means niya, yung means ng bawat predictor. Ito naman, yung variation, yung variance. Okay? So, magkaiba yung tinetest nila. And as I said, we will not see the difference when you have only a simple linear regression. Kasi, dito ang null hypothesis natin, B1 is equal to 0. Dito, B1 is equal to 0 din. Pero pag multiple regression na, iba na yung test sa t-stat. No? Sa t-stat, kunyari, you have, as I said a while ago, you have three variables, you have three independent variables. Ang test of means natin dyan, ang hypothesis test natin will be B1 is equal to 0. Isa yon. Tapos B2 is equal to 0. That's another one. B3 is equal to 0. That's another one. So, separate sila. Okay? Pag dito sa ANOVA naman, ang ano natin, ang test natin dito, B1 is equal to B1 is equal to B2 is equal to B3 is equal to 0. So, overall, no? Sabay-sabay sila, no? B1 is equal to B2 is equal to B3 is equal to 0. That's our null hypothesis here. Ang alternative hypothesis natin dito, at least one of these is non-zero. That's for your ANOVA, no? Which uses the F-stat. Ito naman, dito sa regression natin, T-stat ang ginagamit natin, it's a test of means, no? So ano yung null hypothesis natin dyan? H null, B1 is equal to 0. H null, B2 is equal to 0. H null, B3 is equal to 0. So separate yung mga test yan, individual t-test yan. Ito, overall goodness of fit test. Iisang test, no? Okay? Did that answer your question? Sino may nagtanong nun?
Yes, sir. Thank you.
Okay, sige. Good. Class, thank you for that question. So, I'm happy that you asked that kasi importante sa atin na naiintindihan natin yung ano nangyayari dun sa t-stat, anong tinetest dun, ano naman dito sa ANOVA. Okay, there's another way to do this. Okay, we can make use of the CAR package, no? So if you have not installed CAR, paki-install. In-install ba natin dito yun sa simula? Yeah, install natin si CAR. So once we have installed that, then we can now make use of this sa CAR class, capital A siya, sa stats package small a. Okay, so if we run this, okay, pareho lang siya, okay? Pareho, magkaiba lang yung pagka-present. Dito, inuna lang yung sum of the squares, tapos degree of freedom, tapos F value. Dito naman, degree of freedom, sum of the squares, and then meron pa ditong MS, no? Mean square. Dito, hindi na binigay yung mean square. Okay? No more mean square. Dumiretso na sa F value. So, ibig sabihin dito, ginawa na niya, sum of the squares divided by degree of freedom, tapos divided by sum of the squares ng residual divided by the degree of freedom to get your F-stat. Okay? All right. So whether you use the CAR package or the stats package, you'll generate the same answer. Mas kompleto nga lang sa stats package kasi binibigay sa atin yung mean square, no? Mean square. All right. Any questions so far, class? Paki-chat naman please kung clear tayo so far. Okay, waiting for the others to chat, class. Okay, isa lang nag-clear. How about the others, class? 12 o'clock na kagad, ang bilis ng oras. So, still so many things to compute. All right, thank you, thank you. All right, may question ako dito, class, ha? Yung iba kasi dito makukuha na natin. All right, this one. Yung regression output natin, take a look at this. So, alam na natin to, di ba? Alam na natin itong degrees of freedom na to. Check na sa atin yan, no? Check na. Only sa F-stat, sa ANOVA, dalawang degrees of freedom. DF1 and DF2. Okay, sa T-stat, sa T-analysis, no? Sa individual T-test, isa lang yung degree of freedom. Sa F, dalawa. Dito, merong sa F-stat, merong residual standard error. Ano to? Saan nanggaling to? This is actually, class, this is your mean square ng regression, okay? And then get the, okay, kasi ano to, variance to, no? And then just get the square root of that. Okay, please look at the F natin, ANOVA table. What's the mean square regression? Sorry, mean square ng mean square, sorry, this is MSE, sorry. MSE, residuals to, no? MSE. What is the mean square of the regressor, of the regression? Class? Check your ANOVA, please. Yung analysis of variance natin. Di ba merong degree of freedom doon? Okay, DF. Okay. Meron tayong DF doon. Merong sum of the squares. Meron mean square. And then yung F. And then yung P. Okay. Lima yan, di ba? 1, 2, 3, 4, 5. Yung MS, so this is your regression. This is your residual. No? Regression natin, DF natin 1. Residual natin, 524. Okay, and then may SS value tayo. Okay? So MS natin, MSR will be, MS regression will be sum of the squares ng regression. So this is your SSR divided by your degree of freedom. Diba? Ito naman, SSE, sum of the squares of your error divided by your degree of freedom. So meron tayo ditong MSE, MSR, regression, at saka MSE, error. Ano yung MSE natin, class? Paki-chat nga please or unmute. Ano yung value na? Class, hello. MSE, class, MSE. Mean square. Tagal. May sumagot ba? Baka natatakpan. Wala pa nag-chat. Please. Come on, class, come on. MS class, MSE. Go back to your ANOVA class. Tingnan niyo ANOVA. Di ba nag-create pa nga tayo ng object doon?
3.378, sir.
3.378? Saan mo nakita yung 3.378?
Residual po. Standard error.
Hindi. Ang dinedetermine natin how this was obtained. Diba? Take a look at your ANOVA. Ano yung ANOVA natin, class? Di ba sinolve natin yung ANOVA? Ito, class, oh. In fact, ito. Ayan, di ba? Yan, oh. MS, di ba? Ito yung MS regression. Ito yung MSE. Ano yung MSE natin? Mean square ng error, class. Hello? ANOVA. Ano yung object natin? We call it ANOVA 1. Tapos ano yung mga laman niya, class? Ito, mean square, di ba? Mean square. Yan. Dalawang mean square natin. Kung i-subset natin. Okay, dalawa natin. Oh. Di ba dalawa yan, no? Yan. If we only want one, o yung pangalawa, yung number 2 lang. Oh. Which is your 11.414. Right? Ito class yung MSE. Okay, so let me call that I'll call this MSE, mean square error. Yan, binigyan ko ng pangalan, class, no? Enter. MSE, print, 11.414. Okay? And then, okay, I'm going to Others call this standard error of your residuals or residual standard error. Pwede rin residual standard error at minus. It's equal to the square root. Small dapat. SQRT. Square root of your MSE. Okay, how much is that, class? How much is that? Yeah, oh, yes, LJ. Ito yung ano, yan yung ano, yun yung mean square error natin. Pero ang tanong ko, saan ang galing tong residual standard error? Kasi meron tayo dito sa T, ano natin, sa regression output. Pinagsama niya, ito, meron tayong regression output based on the T statistics. Meron din tayo ditong based on the F statistics. No? Ito, saan ang galing tong 3.378? Can you please tell me, class? May clue na tayo dito, residual, di ba? Tapos, residual standard error. Okay, so how did we get this, class? Get the mean standard error. Okay? Ang mean standard error natin, ito, pinakita ko na sa inyo, di ba? Based on the ANOVA, ito. Okay, dun sa, ano, dun sa, yan, class, 3.378. Isn't that, class, this one? Ayan, no? 3.378. Okay? So alam natin kung saan nanggagaling to. Galing sa ANOVA to, no? So if we perform ANOVA, tapos kunin natin yung, alamin natin degree of freedom 1, degree of freedom 2, kunin natin yung sum of the squares ng regression at saka sum of the squares ng residual, tapos kunin natin yung MSE nila, MSE, MSR, MSE. Okay? So you'll be able to get your MSE, mean square error, then you get the square root of that. You now have your residual standard error. Square root lang to ng MSE. Okay? So ito, alam natin to, no? FStat 103.4. Okay? Degree of freedom 1, degree of freedom 524. So DF1, this is the number of predictors. 524. Ito lang yan, n minus k minus 1. Tapos ito yung p-value, which we're going to show in a while kung paano nakuha yan. Okay? Alright, so more or less, class, itong whole yung anatomy na to, itong regression output natin ito, we should be very comfortable with this, no? Dapat alam natin kung saan nanggagaling yan. Okay? We should know where those are coming from. So punta na tayo dito, class. Yes, any
Sir?
questions? Yes.
Sir, could you go back to the formula for RSE?
RSE, okay, sige. RSE. Ito. Here.
Okay, sir. Thank you po.
Okay, nanggaling yan sa ano sa MSE, no? Saan nanggaling si MSE? Kay ANOVA, no? Yung analysis of variance ng regression model natin. Okay? And ito, we can get it from, kasi nag-create tayo ng isang object na ANOVA, and then si ANOVA 1, it's a data frame. Class, okay? Ano na to, yung application na to ng mga ano natin, ng mga previous lessons, no? Class ni ANOVA, it's a data frame, so ibig sabihin, ano ba laman nitong ANOVA na to? Names. ANOVA 1. Okay, so ito yung mga nangyari dito. Ayan. Ito yung mga laman niya, no? Meron siyang degree of freedom, meron sum of the squares, meron siyang mean square. Okay? Ito, alam natin kung paano makukuha to. Mean square is just your sum of the squares divided by your degree of freedom. Okay, so punta na tayo dito, class. Alamin na natin tong sum of the squares, no? Alright, how was this obtained? Sum of the squares. Sabi natin tatlo yan di ba? Itong SSE, SSR, SST. So before we do that, i-plot muna natin, class. Let's plot again para mas makita natin, no? Okay, so let's plot. Let's create a scatter plot. Control Alt I. Okay. So plot natin, plot si Okay, i-attach muna natin si wage siya para ano, attach wage so that we don't keep using the name. Plot natin si, okay, ang x-axis natin si education, and then ang y natin si hourly wage. Okay, lagyan natin ng label x lab is equal to years in education, years, the education, number of years, number, o bahala na, no? Years in education. Okay, tapos lagyan din natin si y lab is equal to hourly wage, tapos lagyan din natin si main is equal to a scatter plot ng hourly wage versus education. Okay. All right, so we have plotted this before, di ba? Ito. Na-plot na natin yan. Okay, sige, pause for a while. Yan, bigay ko na to kasi anyway, alam na naman natin yan. It's something not new for us. Chat ko na lang class so that we save on time. Okay. You may copy that, please. So this will be our plot now. Our mass from wage. Okay. Any questions so far about the plot? How time flies. Fast. Bilis. Hindi pa tayo nakaka-SSR, SSE. Okay. Okay, clear so far, class? Paki-chat naman para alam ko kung tutuloy na ako. May I continue now? Were you able to get this? Feedback, please, class. Hourly wage, yung dependent variable natin, nasa y-axis. Regressor natin, si x. Simple regression lang to, no? Kasi kapag multiple regression na class, kunyari, kahit bivariate, no? Well, ano siya, 3-dimensional na yun. And that will be very, very difficult to plot. Lalo pa class kung ano, kung 5 o 6 na kaya hindi natin napaplot class kapag multiple linear regression kasi iba't ibang planes na yon, no? It would be really very, very difficult to really see. Okay. All right. So, kasi ang objective natin, how do we explain hourly wage? Diba? So, may option tayo. Number 1, okay, gamitin natin si education. Okay, as our predictor. Isa lang muna si education. So ngayon, ang tanong, kailangan ba natin si education o pwede nang si hourly wage lang gagamitin natin? Diba? Kasi pwede naman natin gamitin si hourly wage lang. So let's not make use of education as a predictor. So what's the option? Di kunin na lang natin average ni hourly wage, diba? Okay, so isama natin dito class, no? Let's now create a plot, AB line, okay? AB line tapos horizontal natin, horizontal line will be our hourly wage. Tapos, gawin natin line width. LWD is gawin natin 3 para medyo makapal siya. Tapos, color gawin natin blue. Okay. So, I'm going to add to this one Okay? A line. And H stands for horizontal. Pag V, vertical line yan. Okay? And, sorry. Ang horizontal line natin dapat yung average, no? Mean ni hourly wage. Okay? So, ang gagawin natin, class, kasi ang gagawin nating predictor, si hourly wage. But what value of hourly wage? Eh, di kunin natin mean na lang, mean ng hourly wage, no? In fact, we already got this, diba? Mean, pwede natin kunin yan, kasi nag-attach na tayo ng, we already attach wage. So, ibig sabihin, you can make use of, pag ginamit natin any variable under wage, maiintindihan ni Aryan, kasi naka-attach tayo, di ba? Nag-attach tayo yan, no? Attach wage. So, this is, yan, 5.8896. That's the average. So, pag isama natin dito, no? Okay, mag-create ng line, okay? Horizontal is the mean of hourly wage. Length ng width, okay, is equal to 3, tapos color is equal to blue. So, i-run natin to, no? Let's run this. All right, so you can see here. Okay, yan. So, what are we doing here, class? Anong ginagawa natin dito? Okay, ang sinasabi natin dito, okay, so if we're not going to use any regressor, if we're not going to use any independent variable, then pwede natin gamitin si hourly wage na lang as our predictor. And this is, di ba, 5.8 something. Diba yan ang value ng So whatever, it doesn't matter kung anong education, it doesn't matter kung anong race niya, it doesn't matter kung anong gender. Whatever the scenario is, ang gamitin natin na predictor is average. Class, sandali lang a minute. Okay, sorry about that, class. Okay. Ito yung natin, no? Ito yung, okay, can you hear me, class? Is my screen still showing? Hello?
Yes, sir.
Okay. All right. So, you can see here, class, that ito yung mga actual points natin, di ba? Actual natin to. So, actual to. Actual. Gawin kong pula yan. Tapos, ang prediction natin dyan, ito. Yung average. So, bawat isa dito, class, ito yung actual, ito yung predicted value natin. Meron tayong mga, ba? May mga tayo, class, may mga maling prediction. Kasi ang ginagamit lang natin yung average, di ba? Just the average. So all the points here that does not touch the average, mali yun. No? Okay, so the difference between this, so what's this, class? This is your y sub I. Yung mga actual natin. I-minus natin sa average. Yan. Y sub I minus average. Okay? You will get, pag i-sum up natin yan, class, you'll get a zero value. So we don't compute for that kasi yung average, ang meaning niyan, class, ng average If you get the differences between the points above minus the points below, it will add up to 0. So we don't get that. Kasi wala tayong information makukuha dun. Instead, class, we get the square of that. Square. Yan, okay? Pag in-square natin yan, syempre hindi na 0 yan. No? Kasi yung negative dito, magiging positive yun eh. Okay, so may tawag dito, class. You have a special name for this. The difference between your actual value from the mean, this is called your SST. Sum of the squares, no? Square siya, di ba? Total. Okay? So this is now the sum of the squares of your total. This is the total variance. Okay? Ito yung total variance ngayon. Okay, pause muna ako, class. Clear? Clear yan so far? Paki-chat naman please, faster please, para ano? Kasi baka may mga questions kayo and bilisan lang yung response time. Okay, klaro ba class? Yung difference nila na naka-square, ang tawag dyan, SST, sum of the squares of your total. Yung iba ang tawag dyan, total sum of the squares, TSS. No matter what they call it, class, basta importante, that's a difference between your actual point minus your average. Okay, bakit average? Kasi hindi natin gagamitin yung mga we're not going to use any of your independent variable to predict your hourly wage. Okay, 6 lang yung responses. Konti lang Okay, clear drawings. Okay. All right, next. Okay. So, this time, class, ang gawin natin, magdagdag na naman ulit tayo ng AB line, no? Idagdag natin AB line, okay? AB line. Tapos, di ba meron na tayong model 1, di ba? Right, class? We already have our model 1. So we can make use of that. Okay? AB line natin, tapos model 1 is your regression line, di ba? Or you can do this LM that tapos hourly wage regressed on etc. No? And then gawin din natin ang length of width net din natin, gawin natin 3. And then ang color natin is equal to red para maiba lang siya din. Okay, what are we doing now? We're asking R to also draw mod 1 is your regression line. So kung i-run natin to sabay-sabay, okay, what do we now have? Okay, nasama na si regression line. Yan. Ano ko to? Oops. Okay. Hindi makita yung Okay. All right. Okay, so you now have this, di ba? Ano nangyari? Did the use of the regression line improve your model? Okay. So we can now see that ito yung initial model natin, ito. Ito yung initial model natin, di ba? Yung average lang. Ito na ngayon yung bagong model natin. So ngayon, from the initial model, tapos hanggang dito sa regression line natin, okay? Alright? So yan, no? Yung mga points natin, okay? Here. So we can compute for that, no? Yung difference ng sorry. Mali, no? Hanggang dapat dito. Mali ito Ito dapat, no? Ang ginawa natin, in-improve natin yung model natin. Dati kasi ang model lang natin yung yung almost time na pala, no? Tapos yung walang to class, yung from the mean, yung mean lang yung natin. So, kung kunin natin class yung difference ng mean, okay? Yung y hat natin minus the mean, okay? So, yun yung na-explain ng regression natin, squared. This is now your sum of the squares of your regression. Yan. Okay? Yan yung SSR natin. And lastly, okay? Ito na yung bagong model natin, yung red line na yan. Yung mga mali, no? Ito yung actual, tapos ito yung regression line natin. But you can see here that may mga errors tayo, no? Yan. Merong malalapit, may malalayo, okay? If you get the difference between the actual data point and your regression line, and then sum that up, you'll get 0. So what we do is we get the difference ng predicted value natin, okay, minus the actual value, okay, ito yung predicted value natin, minus the actual value, squared natin yan, that's your SSE. Yan yung residuals natin. Yan ang hindi na kaya ng model natin. Okay? So this is your explained variance. This is your unexplained variance. Okay, so next meeting, papakita natin na sum of the squares of your total variance is equal to sum of the squares of your, okay, of your regression. Ito yung explained variance natin plus sum of the squares of your errors, no? Yung unexplained. Okay? So, time na, di ba? Time na ba? Is it time, class? Yeah, it's already time. Okay, so let me stop there. Stop